Algebra 1, 9.1c, intersection of sets and empty sets. So let me show you my little card here. This is an intersection of two sets. So this upside down U shape means intersection, and it's the intersection of two sets, A and B. And you'd write it as A, then that symbol, and then B. And it means this middle period, see, part right here. See that? It's the set of all the members of the set that are common to both sets. All right? So the intersection of two sets, A and B, is written as A intersection B. This symbol means intersection and also means and. You could say A and B. And the intersection of the sets are all the elements of the sets that they have in common. So we have set A and set B here. And set A has got 1, 2, 3, 4, 5. Set B has got 1, 3, 6, 7, 8. And the intersection is this part right here that they have in common. So A intersection B is the set 1 and 3. We read it as A intersection B. So if we wrote it as sets, we'd have the set of A, 1, 2, 3, 4, 5, the set of B as 1, 3, 6, 7, 8, and the numbers they have in common are 1 and 3. See? They have 1 and 3 in common. So that's their intersection. See? That's not hard, is it? All right, let's explain some more. Here's the actual definition of it. For any two sets A and B, symbolized as A with that symbol and then B, A intersection B equals the set of X such that X is an element of A and an element of B. And we can find the intersection of two sets. So if set A, we're going to let A be this set right here, 1, 2, 3, 4, 5, and 6. And we're going to let the set B, it's going to equal -2, -1, 0, 1, 2, 3. Now find the intersection of A and B. Well, we can see they have 1 in common, 2 in common, and 3 in common. So A intersection B equals 1, 2, and 3. We put that in set braces, okay? We can also find intersections of infinite sets, infinite amount of elements in the set. So if n equals all natural numbers, we talked about that in the last video, that the letter n is going to equal all natural numbers. We're going to let z equal all integers. So find n intersection z. Well, every member of the natural numbers is in common with the set of integers. So that means n intersection z is n. It is all the natural numbers. See? I have a video from grade 8 math 1.2b that's going to be, there's a link in this description that explains natural numbers, whole numbers, integers, real numbers, rational numbers. So if you have trouble telling them apart, you might want to watch that video real quick. All right? So what would be the intersection of even numbers and odd numbers? Well, here we have some even numbers, 2, 4, 6, 8, 10, 12, 14. Here we have odd numbers, 1, 3, 5, 7, 9, 11, 13. What do they have in common? Nothing. There's no elements in common to both sets. The intersection is empty. See that? There's nothing there. It's an empty set. So we write it as the set braces with nothing inside of it, or we write a 0 with a line through it. And these sets are disjointed. See that? They have nothing in common. There's a blank space in that intersection right there, okay? Now let's try this one. Let D equal -5, -4, -3, -2, -1. It's all negative numbers. Let P equal 0, 1, 3, 7, and 12. So find the intersection of D and P. Well, they don't have any numbers in common. It's an empty set. So we write D intersection P equals 0 with a line through it to let everyone know that it's an empty set. Now I want you to look at it this way. Here's a map of the U.S. What if you were going to travel between Texas and California and you were going to stop along the way at these dots, at these cities, to rest or to get something to eat? So all these cities along the way were points on your trip. And then what if somebody else drove from Florida to Chicago? And these were all the stops that they stopped at on their trip to sleep or eat. Do they have anything in common? No, they don't even touch each other. So that's an empty set. They're disjointed lines because they don't intersect anywhere. But what if someone drove from New Mexico or Arizona, like down here, and drove up this way towards Montana, and they intersected right here at this city, and they both rested and got something to eat? Well, then that would be the intersection, wouldn't it? That would be the intersection of the two lines. See? We're going to get towards that in a future video when we talk about graphing, okay? All right, so let's look at this one. We've got set A has 0, 1, 2, and 3, and set B has 0, 4, 5, and 6. So what do they have in common? They both have a 0. So A intersection B equals 0. An empty set is completely different than having 0 as an intersection. They do have something in common. They have a 0 in common, don't they? Where the one up here, sorry about the focus, the one up here, there was nothing in common. They didn't even have the 0 in common. See? So that's why it was an empty set. In this one, they do have something in common. They both have a 0. So we write it with the set braces with the 0 inside. Way different than an empty set, okay? So our next video, 9.1D, we're going to talk about the union of sets. And there's going to be a link to that video I told you about that talks about the sets and subsets of all the types of numbers, rational, irrational, and real numbers, and integers, and whole numbers, and natural numbers. That's going to be in here so you can watch it real quick. If you want to see the video about sets and elements of a set, that was 9.1A, or the roster and set builder notation, that was 9.1B, that's going to be in this description too, okay? So I hope this was helpful. I hope you're doing okay with these sets and intersections, and I will see you next video, and we'll talk about unions. Bye.